Alright, welcome back to a new Pewaukee video. And today's we're going to be going over Jump Game, the original, question number 55. So I want to try something a little different this episode and just solve the problem first and then walk through it afterwards so that I'm not doing so many ums and buts and this and that. So yeah, thank you very much for watching this video. Make sure to like, subscribe, and comment your favorite thing about the video or how I can improve my coding. Thank you very much. Alright, let's get started. So, problem is asking us, you're given an integer array of nums, you're initially positioned at the array's first index, and each element in the array represents your maximum jump length in that position. So return true if you can reach the last index or false otherwise. So, given an integer array, we to find out whether or not you can the end index. Yeah. And then each value represents the amount of steps we can move forward. Right, so if we have the first example says we have index 2, or index 0 says we have a value of 2, so we can move 2 steps forward, right? So I want to see if we can reach the end. So let's give an example, and let's say 3, 2, 0, 1, 3, 0, 1, and how am I trying to say? 0, like so. So we start at index 3. So I'll just put an arrow there. And so we go to index, then we go 1, 2, 3. We can do it like this. And then we could say, okay, then go to 3. So let's say we go to 3 and then we say, okay, let's go to 1. Let's see. And then we go 1 over. And then we go 3 over. And then we would reach the end index, we would say true. Alright, and then let's try another example. So let's say 3, 1, 4, 0, 2, 1, something like so. So if we have 3, right? So if we start at 3, let's do it like this. And then we will go to 0. So it'll be false, right? Well, actually, that's not the idea. We'd have to kind of get this 4, and then we have to skip over, right? So let's say if we go 3 and then we go to 1. So let's say instead of these, start at 3, and we go to 1, go to 4, and then we can go 3 over 3. Since 4 is greater than 3, this would actually be true. And let's give one more. So here we start at 2, and then if we went to index 0, we get false. Okay, that doesn't quite work. Let's start at 2, and if we go to 1, then we'll again go to 0, and then it'll still be false. So this one will be false. But the idea now is how do we actually optimize, in this example, how do we optimize to get 4, and then we keep going. observation could be cannot skip, let's say nums I in the array, or cannot skip nums I position your next index. So in this example, we'd end up at 0. That's not good. So what if instead we use the max? What if we use max to find out the maximum number of steps that we could travel, right? So if we had an array like so, add one, let's say 2, and then we had let's say like 3, and then we had 4. Wait, what did I say? Oh no. Instead, we had 2, 4, 2. And we had something like this, right? So if we had start at 2, if we went to 2 here, and we would end up at this 0, false. But we want to kind of get the maximum 4 here. So if we went to 2, then we went to 4 and we had 4 steps, and we would get to the end. So that would work. Yeah, that would work. So this would be true. So what if we used a max, right? What if every time we stepped, right, we found the maximum amount of steps that we could take? That could be a good idea. Let's outline some steps. So I'm going to say define steps remaining, or steps left, to be the length minus 1, right? Say in this array of 6 elements, we need to do 1, 2, 3, 4, 5 steps. And then we're going to define available steps. Available steps to be the first index. The value, the first index. And then we're going to want to loop through. So we're just going to say define a loop. And then in that loop, we want to say basically our base case, or how we return false, is something we need to consider. So how do we return false? We return false if we end up at a 0. But however, if we end up at a 0 and it's at the end, we'd return true. So we just want to say define a for loop, and then if the steps available, we'll say avail is 0 and not at the end, return false. So that means that we cannot reach the end. Okay, how about returning true? So return true if the available steps is greater than or equal to the steps left. Right, so this means that we can get to the end, so we would return true. And then we'd want to say that the steps available, we'd want to redefine that, right? So every time, so here we go from 2, then 4, so we want to redefine the number of steps available to be 4, or the maximum value. I say steps available equals to the max of steps available minus 1 and nums I plus 1, so the next element And this -1 is because if we're here, right, and we do 2, basically we're simulating taking a step forward. So we would go to 4, but our steps available from the 2 position would only be 1 at index number 1, where the 4 is. And then we'd want to say the steps left be decremented. So let's try and implement that in code. So the first step would be find steps left and steps available. So int steps left equals, so we said to be the length of the nums, -1, and int steps available equals to the first element, say num0. Then we have to define the loop, thinking Python here, in the comment, define the loop, say for int I equals 0, I less than nums.length, and I plus plus. Actually here we can say nums.length -1. The idea is for that is that we actually don't need to ever, wait, yeah, wait, no, wait, actually I think we do need to include it, excuse me. So our false condition, if the available steps is 0 and not reached end. So if steps available equals 0 and I is not equal to nums.length -1, which means it'd be at the end, right? Then return false. And then true condition, if the available steps is greater than 0 or greater than steps left. So if available steps is greater than steps left, then we're going to return true. Okay, we're going to return true. And then we're going to say find the maximum value between steps available and next index. So we're going to say, actually, oh, this should be equal to. And actually this can be -1 or -1, because if we think we're at the second to last index, for example, if we're in nums.length -2, so long as that's 1, we can reach the end. So this will be true. We'll return true at that iteration. So we can just, oh yeah, so then we won't have an error right here where we'll say available steps is going to be equal to the max of available steps. It's steps available. Steps available. Available -1, and then we're going to say that the maximum between steps available after taking after stepping, and the next index, and we're going to say nums I plus 1, and then we're going to, we're at a semicolon, and we're going to decrement steps left. So steps left minus minus. And then for our default return statement, we're just going to say return false. Although this should really never happen, but we're just going to put false. So let's try and run some test cases. Let's run the first two. Or let's just run the first one. Actually, no, we should do one true and one false. So it should, oops. Oh, this is supposed to be steps available. Again, available. This is what happens when you just try and submit right away, you'll get that error. Okay, true. And then let's run this one here. And we should get false. If we do, let's try and submit. Alright, let's give it a shot. It should work because I have done it before. So, oops, forgot the base case. Base case. If len is 1, return true because we're already at the end. So if thumbs.length was 1, return true. And should be good now. There we go. Faster than 92%. That used to be a lot better. It used to only be 42.8, but that used to be like 90% better, but only 10% better this time, I guess. But that's okay. A very fast solution, so that's good. So, quick run through. Base case if the length is 1, we just return true, and then we're going to define steps left and steps available to kind of keep track of how much distance we need to travel in the array. And then we're going to define a loop, and then we're going to say, right, if the steps available is equal to 0, which would be gotten from the maximum amount of steps that are available, or the first index, right? Then we need to say that, yeah, so long as it hasn't reached the end already, return false. Okay, and then, actually, this statement should not be needed, I believe, because it'll never actually be equal to that. Yeah, I don't think this should be needed. Yeah, I want to try this, see if. Okay, cool. So, because actually it never goes through that iteration, so long as steps available is equal to 0, then we're just going to return false. Because we already would have reached the end by checking this statement in a previous iteration. That makes sense. So basically, if the steps available is greater than or equal to the steps left, we good, return true. And then we want to set the steps available equal to the maximum between the steps available minus 1 and then the next element. And then we want to decrement the amount of steps that we have remaining because we've officially, I guess, completed the loop, right? So we just go 1 to the, I think the camera's flipped, so 1 to the right. I'm pretty sure. But anyways, that will be the video today. Thank you very much for watching, and take care.